My name is Justin Smith, and for the next few minutes, we're going to talk about how we can use the new features in the .NET Framework 3.5 to build applications and more specifically services. If you have any questions, comments, or personal attacks about this session or the technology in general, please don't hesitate to contact me via my blog. The address is up there on the screen. I'm a technical evangelist with Microsoft, and my area of focus is really anything that's service related. So I really live and breathe service-centric stuff every day. Make sure I got the right clicker here. I've split this talk up into 4 buckets, if you will. The first one is what's in 3.5 for services. We've been talking about services at Microsoft for quite a while, and I think with the 3.0 and specifically the 3.5 release, we've got a fantastic story for services in lots of different fashions. So we've got this capability now in the .NET Framework to build all kinds of services. And then the next bucket there is our new HTTP programming model. So we've added an interesting HTTP API to WCF. This was mentioned a little bit yesterday in the MySpace talk and how they implemented a RESTful API in their developer platform. And then we'll also talk about what's new for JSON services. So we have a new serialization stack and new integration with WCF for JSON messaging capabilities. I'm assuming that everyone in the audience here is familiar to some degree with JSON. And then last but not least, we're going to talk about one of the features I think has the longest reach, in particular on the web, and that's the syndication support in the .NET Framework 3.5. So there's a new syndication API, finally, as part of the platform, right? So you don't have to go and try to roll the capability yourself with XML readers and XML writers. It's just in the platform. And I think regardless of your vision and how you're going to use services, I think more than likely you're going to use the syndication API if you're using the web, which everyone here at this conference is. So I think the syndication support probably has the longest reach. Now, before we talk about services in more detail, I want to kind of pose a question, and I pose this question at every single talk that I give on services. So if you've been to one of my talks before, you've probably heard this question. Somebody walks up to you on the street and says, I will give you $1 million if you can tell me what a service is. What would you say? You would say yes, okay. Please. What else would you say? Like, how would you define a service if there's $1 million on the line? Maybe somebody had a good night at the casino last night. Let's say it's $5 million. That makes more of an impact. Well, it's actually a hard question to answer, right? Because we've got a lot of different flavors of services that are out in the world. Most of the time when I pose that question to an audience, the response comes back with something like HTTP. So there has to be some support for HTTP. I love HTTP. We think it's great here at Microsoft. There's no bias in any way, shape, or form against it. But also there's the notion of SOAP or REST, one of those two camps. And in our view, services are actually a really, really broad set of capabilities. And the way I defined a service, at least this is the way I defined it in my book, and I haven't seen anyone poke too many holes in this part of the book, it's a service is some functionality that's exposed via a structured messaging scheme. And that functionality could be shared over any transport, whether it be HTTP, TCP/IP, MSMQ. You basically insert a transport here, and that's a viable target for a service. The structured messaging scheme could be something like what's defined in HTTP, where you have a request and a reply. It could be some sort of an architectural style, like with REST, where you're using the HTTP constructs like headers to add extra information to a request or response message. It could also be something like a SOAP world where we add SOAP header blocks. So the idea of a service is really something very broad. And when we look at the traditional trajectory of the evolution of our services stack at Microsoft, you could almost liken this to the evolution of man graphs that you'll see in different textbooks. Right? We started clearly with sockets. If you want to build a service and you want it to communicate with other applications, you could, if given enough time and resources, go use the Sockets API and God be with you, because you're going to have a long road ahead of you. It's really cool. It's really fun. You had to do it in college. And in some cases, you'll still need to revert to that model if you're doing something highly specialized. But in the idea of trying to further developer productivity, that wasn't quite good enough for our stack. So in XP Service Pack 2 and Windows Server 2003, we have this thing called HTTP Listener that makes it a lot easier for us to build services on the Windows platform. There's a whole new model shift with the HTTP Listener and how we set up HTTP traffic and listen for HTTP traffic. That's there. You can still use an HTTP Listener today if you want to build a service, but you've got to write a lot of plumbing yourself. You've got to do all the threading yourself. You've got to do a lot of the security yourself, the identity and the access control. It's all got to be done by you. It's kind of a pain in the neck. You can also use ASP.NET. Now, the reason I put ASP.NET on this slide is it's built for rendering rich web content, right? It's great for developer productivity, and it's great in rendering all kinds of really cool HTML, and you've got now capability with things like Silverlight 2. It's all just fantastic. But you could also view ASP.NET through the lens of a service platform that's geared towards HTTP traffic, right? So you could build a data service, if you will, or a functional service using ASP.NET. But you're not really going to have lots of service-centric capability just built into ASP.NET. In other words, how do I take care of sophisticated serialization tasks? Well, okay, I'd have to go roll that myself. How do I make the developer API for using ASP.NET in a servicey kind of way? How do I make that easy to use? Well, that's kind of what ASMX was. So if we go a little bit further up the stack. And ASMX was all about building HTTP basic profile services, right? So those are SOAP-centric services that really plug into the ASP.NET pipeline. But one of the problems with ASMX is how do we address this broader service world where the transport could be anything, the format of the messages could be anything, right? And how do we make sure that we can deal with lots of different kinds of hosts, not just IIS, right? And so this is where WCF comes along. WCF provides this massive capability when you're building services. Whether we're talking about stuff like the web, like we're talking about here, or we're talking about something that will happen inside of a data center where we need really machine-to-machine kind of connectivity, or when we need durable stores. WCF can do all of that. It's all that and a bag of chips. It's fantastic, right? So when I look at the evolution, or when I think about the evolution of a service stack in Microsoft, this is how I view it. You can certainly use any of the other stacks if you'd like to, but WCF is where it's at. Now, where's the evidence of this? I'm often asked, well, why would I use WCF over something like ASMX or ASP.NET? I'll tell you this. All of the server products that I can think of in my head at Microsoft are using WCF. Can't go into too many details with that. When you look at ADO.NET data services, what do you think's the plumbing behind that that's exposing all those services? It's WCF. The SQL Server data services stuff, the stuff that's sitting behind the public REST API and the SOAP API there, that's WCF. So internally at Microsoft, we are taking deep bets on WCF, and there's also adoption out in the community. So that's how developers inside of Microsoft that are not on the WCF team feel about WCF, that it can address that broad range of service tasks. Really cool. Okay, so that's my view of WCF. And if you look at it in a nutshell, just to summarize, it's kind of a one-stop shop for services. And if somebody walked up to me on the street and said, Justin, I'm going to give you $5 million, because $1 million wouldn't go very far in Seattle. So I'm going to give you $5 million if you can tell me what WCF is all about and what's the value. It allows you, the developer, to focus on the functionality of your application, and we'll do what we can to take care of the plumbing. We being WCF. So that's really the value pitch of WCF. And it's got all these great manageability features like debugging, like great tracing support, like built-in denial of service remediation capability, built-in capability for threading, right? All that stuff's just wrapped in the package, and it's part of the .NET framework. So that's kind of WCF in a nutshell. Now, why in the heck are we talking about WCF when we're here at a web-centric conference? Well, there's a myth that's flying around that WCF is only for enterprise services, right? And I want to ask a question now. Who here has used WCF? I should have asked this a little bit earlier. Who here has used WCF for web-centric stuff? Okay, so we've got about 2/3 of the room, WCF. Is anybody a WCF expert? Like, you'll stand up and say, I know WCF like the back of my hand. One. Okay, and I know Eugene is back there, so probably him as well. Right, so it's a pretty sophisticated stack. But there's a myth that's flying around that WCF is largely only for enterprise space. And the reality is WCF gets around. It's like my ex-wife, right? WCF gets around. It does enterprise and the web. And in .NET 3.5, I apologize if she's listening. Not really. There's a few web-centric upgrades in .NET 3.5 that we've added specifically for addressing this web space. First, we want to make REST a first-class citizen. We want to make REST, we want to embrace REST and allow you, the developer, the flexibility to make your app 100% part of the REST architectural phenomenon that's happening. So we want to make that possible in this stack. We want to make it really easy in this stack, because it was possible in 3.0. We just want to make it easier. We also want to embrace SOAP-less representations. Now, I really struggled with the right grammar on this slide. Non-SOAP sounds a little bit odd, but SOAP-less is about the best I could do. So if you don't want to do SOAP, we want to have that serialization support there. And this could take a lot of different flavors. It could take the shape of JSON messaging capabilities. So I want to use JSON for communicating with the Silverlight app or ASP.NET Ajax or anything else that's on the web. Maybe I also want to just work with POX, plain old XML. So that's all there too. We've got that baked into the framework. And also, what if I'm trying to build a syndication, right? How would I do that? Well, now with WCF and the capability that's now in our framework, it's the way you go. WCF's the way to go. And last but not least, I put this on the bottom of the list, not because I think it's least important, but there's only so much you can say about it. WCF now runs in partial trust, specifically ASP.NET Medium Trust. Now, not all of WCF, but a subset of those features run in partial trust. What's the value there? If I want to go use a hosted web server, I'm probably not going to have full trust on that web server unless I've got the whole server, right? So if I go out to one of the big hosting sites and I provision something and I slap a WCF service in there, if I'm using the RESTful API or the syndication capabilities, it'll run in that sandbox. It'll run in that code access security sandbox now. So that's really cool. And a lot of this, guys, was driven off of community feedback. So we got a lot of feedback from the user community saying, this is the stuff that we want, and we hope that we listened. Right? So that's the model. If you have additional feedback about what you'd like to see in the services stack at the .NET Framework, tell me. Let us know. Because we rely on you to drive the features in this framework. All right. Let me fast forward one more. So let's talk a little bit about the new HTTP API. And this is part of how we embrace REST in the framework. So we want to promote web concepts to being first-class citizens in the framework. And you can view REST through a lot of different lenses, right? You can view it through a very detailed, very feature-driven kind of way. But when I think of REST, especially to an audience like this, I try to leave it fairly open-ended. And there's 3 takeaway points that I think you should focus on when you're thinking about REST. This is just a subset of what REST is. First, you've got to embrace the URI in your applications. So the composition of a URI will map in some way, shape, or form to application logic. And in the .NET Framework world, we've got to have a way to bridge the object-oriented world to this RESTful or web world where URIs are very, very important. And so we've got that in WCF, and I'll show you that in a minute. Next, you need to work with HTTP methods. So get and post are by far as traffic goes on the internet, the two biggies, get being by far the biggest, and then followed as a distant second, post. Put and delete are still there. They're still important, but most clients are using get and post, right? And yesterday, the MySpace discussion talked about low rest and high rest. I'm not going to go there today, but imagine a stack that's got support for those HTTP methods in a way that bridges the object-oriented world to the HTTP world. And then last but not least, you got to work with response codes and headers. And you can view this like the content type header, HTTP header, is really the data model for this web-centric world. If you go to the SOAP-centric world, the data model there is WSDL, right? Now that requires a stack on the client and the server. Sometimes that's not going to work. Sometimes you need broader sort of capability. But content type works pretty darn well for this. And I'll drill more into what I'm talking about there. But when you think of REST, if among the things you're thinking about are those three concepts, then you're on your way. Okay? And we also want to allow SOAP and POX from the same contract. And the idea behind this bullet is if you choose a RESTful approach today, we don't want to preclude you from taking another approach tomorrow. So we don't want to force you to go down a path. If your requirements change, you still want to be able to adapt to that path. So the concept is you can do WS star SOAPy kind of messaging and RESTful messaging pointing to the same functionality. Now that doesn't always work, but the capability is there in the stack. It all really depends on how you build your application. So we didn't want to preclude you. Okay? So, how do we model a URI in .NET 3.5? That's one of our core concepts. There's three types that we include in the .NET framework now. The system.URI template, URI template match, and URI template table. Anyone notice something odd about the namespace there? It's not like system.service model. Since most of us who use WCF, that's one of the key namespaces in WCF, right? So we thought that the URI template and URI template match were so important that they shouldn't just reside in the system.service model namespace, right? Even though they're in a system.service model assembly. Okay? So the system.URI template is a way to match the structure of a URI ultimately to some application semantics. Just know that's one of the core types that's in our new RESTful capability in WCF. Now it's got some methods defined on that type, like bind and match. I'll show you how those go in a minute. But the idea is I can use a URI template to create a URI that's fully populated. Has anybody tried to parse URIs by hand and create URIs by hand? Is it fun? Is it a really productive task? Do you get it right the first time? No. It's kind of a pain in the neck. So URI template is a way to build URIs. Now, URI template match comes from the match methods on the URI template type, and that's for trying to parse values out of a URI. Okay? And then there's the URI template table. I'll show you a little more about that in a minute. But that's the concept for how we work with URIs in WCF and even in the .NET Framework 3.5. So you can use this totally separate from the WCF stack. Here's how it works. So this is just the URI template and template match on its own. So I'm not using WCF here, but I think these types are so important, I'll show you how to create a URI. Now the first line of code is not that sexy. New up an address. Whoop-dee-doo. Okay? We new up an address, and then we're going to new up a URI template. Now that URI template takes in its constructor a string. Now the string really models two URI segments. So we're going to new up a URI template, and we're going to pass a string that says we've got a URI segment called artist and another one called album. Okay? Now we want to use that URI template to create a URI. So we call template.bindByPosition, that instance method, and we pass in the address. We pass in the address and pass in two values, Northwind and Overdone. Because this is a Microsoft conference, we've got like 3 companies that we can use, Northwind being one of them. So they're a band. I don't know if you guys knew that too. and their new album is called Overdone. So the resultant object from the bind by position method is a URI, and if we write that URI out to the console, we see localhost 2000 Northwind Overdone. So this is a really easy way to create URIs. We can also use query string parameters. There's a lot of cool stuff we can do here, and also wildcards. Once we've got the URI, how do we parse it? How do we get some values out of URI segments, whether they be query string parameters or actual full-on segments? Well, we call the template.match method, pass in a base address, and we pass in the URI that we just created, the one that's got values in it, and we get back a URI template match object. And then we can go through and extract values using the bound variables API bit there. Right? So we can go get Northwind. And it just works. So it takes care of all the character encoding concerns, HTML encoding. All that stuff's taken care of for you. Pretty cool. Now, how do we map that URI template capability into WCF? Since we've all used WCF, or most of us have used WCF, we know this idea of a service contract. Well, we can take an existing service contract. You know, we got our service contract annotation and our operation contract annotation, and we just add a couple of new attributes on there, like webGet is one, webInvoke is the other. But I want you to focus on the URI template capability. So there's an instance property in the webGet attribute called URI template. And we can pass in a string or set that property to some value, and that's going to be used at runtime in the constructor of a URI template object. And notice the name of our different segments maps to the arguments in our operation contract, which is pretty cool, like real easy to use, right? So there I'm saying my URI is going to be /image/artist/album, and it's going to map into my method as arguments. Really cool. So that's how we bridge between a URI and a method. Question? So the question is, will they be checked at compile time or will they be checked at runtime? They'll be checked at runtime because what does an annotation actually do? What does an attribute actually do? Well, it's a good time for me to do my impression. Right? So here's my impression of a custom attribute. I know the guys that I work with are just thrilled to see this again. Here's what a custom attribute does. It bloats metadata. It adds metadata to the assembly, and we reflect over that metadata at runtime, and we've got rules built into the WCF infrastructure to say, is there a check here? Do they line up? If not, we throw. We don't start listening. So with attributes, we are sort of removed from the compile time world, and we're moved into the runtime world. Very good question, though. Notice also down at the bottom, we've got image name, image question mark name equals artist. So we can also use query string parameters if that's our bent. Pretty cool. So that's how we map a URI template into a WCF contract. And again, this bridges us from the world of HTTP into the object-oriented world. Now, remember our second concept that we think is really important in making REST a first-class citizen. That's embrace HTTP verbs. Get, post, put, and delete, and all the others. So we've got two different annotations that will help us down that path. The first is webGet. If you were the reckoning sort of person, what would you reckon the HTTP verb or method that webGet maps to? Well, it's probably a get, right? So webGet maps to an HTTP get, and we have this other attribute called webInvoke that maps to all the other HTTP methods, right? And so you can define the method instance property of that attribute to be put, post, delete, or anything else, right? And you're basically saying this method is going to listen for HTTP traffic that has the following method, of the following method type. Pretty straightforward. And again, you can use URI templates in both. So we've tried to make this really, really easy. Really, really, really easy. And I think it's a very intuitive model to work with. Now, you might ask, why didn't we have a web put, a web post, and a web delete? Well, the idea is we view kind of the world through two different lenses. There's the idempotent world of the GET, the HTTP GET, where when I invoke that GET, when I perform that GET, I'm not going to have any side effects with that GET. Right? I'm just going to get back a representation of that resource. Whereas all the other HTTP methods have some side effect associated with them. Puts, posts, and deletes. You can read RFC 2616 for the perceived impact there. And so we separate this world into the view it world and the do it world. The world without side effects, the idempotent world, and everything else. So that's why we separated the two. If we see over time that puts and deletes gain more and more momentum, then we're open to modifying this model. But this is just what we think will work today. It gives you all the flexibility that you need to deal with HTTP methods. Now, how do we work with things like HTTP headers and response codes? So again, the talk yesterday, the MySpace talk, went over this just real quickly. But we added a new type in the WCF API called Web Operation Context. The Web Operation Context is sort of a cousin of the operation context that was in .NET Framework 3.0. And I'll show you in a debugging session where that thing actually comes from. But we basically shortcutted the things that we think are most important for developers. Things like the content type header, right? Things like an accept header. Things like a response code. All that stuff is visible through the web operation context.current static property. So you can get at inside your service code and read or set an HTTP header, or you can set a response code using this web operation context type. So really the three key things that we've tried to follow, remember, are model a URI, so make it easy to map a URI into application logic. Right? The second one is embrace the HTTP methods. And the third one is embrace response codes and HTTP headers. So we've added new types in the .NET Framework to do that. So there's a question. So it's a string. It's a string today. It's not a type. So you've got to set that. Yeah, it's not a bounded set too. So that's kind of a problem. We could have built a type that allows you to pass any string and you get something back, and then but it was why. All right. So we've seen some of those core new additions to the WCF API. Now, how the heck do we build an endpoint and how do we host the thing? So we've added a new binding called the Web HTTP binding. It has the same lineage that all the other bindings in WCF do. So it's got a common base type of system.servicemodel.binding. Maybe channels.binding, not sure there. And we also added a service host called Web Service Host. We also added another type called Web Service Host Factory. And I'm going to show you how you use these in a demonstration. But the paradigm here in the model here is we wanted to make it possible so that you could use this RESTful or web-centric capability in WCF with no config. So one of the common things that I hear back from the community is there's a lot of config associated with WCF. And that config has implicit in it a lot of capability. But if you don't want to do any config, we give you the option to not do it, using these types like the Web Service Host Factory, right? And there's a JSON cousin of that as well that I'll show you in a demo. And again, all this stuff works in partial trust and ASP.NET Medium Trust, which is all goodness. Okay, now, there's some tricks to the behaviors that you'll also add to an endpoint, and I'm just going to show you this in demo. Fair enough? All right. First, I want to start off in Visual Studio and just kind of show you how easy it is. Now, there is some discrepancy between what is showing up there and what I'm doing. AV guys? I'm moving my mouse, but it's not moving up on the screen. I switched to C, and that is what's up on my computer. Aha, do demos from here. Very good. Sorry, guys. Oh. Well, I will do an interpretive dance of the demo for you. Here we have a solution. Everybody want to come up and look at my screen? Any ideas? So the problem is I'm moving the mouse on either my mouse or this mouse that's attached, and nothing is happening on the projector. I can highlight something on my screen, but again, it doesn't reflect up there. Switch to a different source. It appears to be locked. Anyone have any questions so far while we're trying to figure this out? Do what? Reboot? The AV box. Reboot the AV box. Well, I'm going to leave that to others. Here. Aha! Son of a gun. It's clean living and a pure heart is why that worked right there. All right. So, we've used WCF in 3.0, and I want to show off something that we're actually quite proud of in 3.5 and Visual Studio 2008. This is going to be the most sophisticated demo that you have seen all of Mix. So I'm going to create a new project, and I'm just going to create a syndication service library. I'll talk more in a minute about what that actually is. I'm going to set that as my startup project, and I'm going to press F5. And what we see here is a simple syndication. Now, from a RESTful perspective, from a web perspective, what have we just done? We've created a project, pressed F5, we've hosted the project, and then we opened a browser and did an HTTP GET for some resource, and we got back a representation of that resource. How much code did I write to do that? Not a lot. So in Visual Studio 2008 and the .NET Framework 3.5, we have a new host built in that acts like Cassini. It's like Cassini for services. It's services that are listening on HTTP or NetTCP or any real transport. We also have built-in support for a client. We have a test client that's really for SOAPy kind of messaging, but we also have a Visual Studio template that will make the client a browser. So the idea is we want to make it really easy for you to get going building a service and not have to think about the host. So if you use this model, use these templates, and use our auto host, you can defer your choice of a host till later. And you get this feedback loop going of saying, okay, I'm going to build some code and see what impact that has on what my service is actually presenting, what it's serving up. Kind of cool. Again, it was no code to really get this done. All right, now I have followed that model into something that's already pre-baked. All right, I've got my standard service contract, very easy, simple little service contract, and I've got a really simple implementation here. In the interviews that I give, I always like to ask .NET developers to reverse a string. So if you ever get asked that question by me or someone else, that's how you do it. So it's a very simple service, very straightforward. Now, I'm going to press F5 here, and we'll see that I get our endpoint not found. Right? So if I zoom in, you can see that's the URI that I went to. Now, why am I getting this? Well, really what I need to do is change the URI. And I need to change the URI to model what's in my service contract. So you might say, what is some method and where is my query string parameter input equal test coming from? Well, I'll show you that in a sec. But let's just go ahead and execute that. And notice we get back a reversed string from test. All right? So how can we impact that URI? Well, the answer is pretty straightforward because it's all tied in our service contract. We didn't specify a URI template in the web-get attribute. Right? If we don't specify a URI template, it defaults to the name of the method as being a URI segment, and then all of the arguments in your method being query string parameters. That's the default. And the reason that's the default is it maps very nicely to the ASP.NET Ajax world. So it maps into sort of a very low rest kind of a world. All right? So that's the default. If I want to change it, it's really, really easy. All I have to do is say, first I got to stop. I say URI template equals, and I'm going to say some, how about I say input. All right. Now if I rerun that service, there we go. So I'm mapping URIs effectively into my method, which I think is pretty cool. It's actually non-trivial to do that. So another kind of cool thing here is I could set a breakpoint. So if I run this one more time, sorry I didn't do that before. I enter a breakpoint. So it's fully debuggable, which is, I think, quite cool as well. So that allows me to step through my code. Now, to the WCF expert in the room, there's the question of how do we morph the 3.0 world of saying we've got channel stacks and the message type. System.serviceModel.channels.message is the core unit of communication in WCF. How do we morph that world into a RESTful or web-centric world? It's actually an interesting question. So we've got this architecture that's defined in 3.0, and there's a lot of extensibility points in .NET Framework 3.0, the WCF in 3.0, right? And so the way we implemented all these changes was using those extensibility points, almost to a T. So we really flexed that 3.0 model to try to get this support into the stack. And we view that largely as a validation of the architecture, right? So we flex that, and hey, we've got now new support there. And let me show you one of the ways that that works. So I'm going to press Shift F9, and I'm going to go into my operation context, .current. And I'm going to go into my request context, and then I'm going to go into my request message. All right, I'll zoom in so you guys can see that. This is something I could do in .NET Framework 3.0. Now I press return, and when I go into the properties state bag, which is something that a message has, it's really a place for the application, for WCF, to add extra information that the infrastructure will use. This is not something that will ever get serialized out to the wire, right? But we've got a bunch of collections in here. And the one I want to tunnel in on is this values, in particular on the third one. Look at what type this third value is. It's of type system.uri template match. Kind of cool. So what we're doing inside the stack is we are matching the request URI and using that to dispatch to a particular method on a service type. So the dispatching infrastructure inside the service model, for those that are really familiar with WCF, we've just used those extensibility points to change the dispatcher. And we're adding what we're matching to into the message. Okay? Now, if we look down here to the template, you look down almost towards the bottom, there's the template property, and that's the string that was used to create the URI template. We can also extract the values, bound variables, right? So we can see that input is one of them. Pretty cool, right? Now, you might ask yourself, where are the HTTP headers in this world? And they are in yet another area of our properties bag. So we've got a particular property that says what's the HTTP method that was used to access this service, right? And we're able to effectively tunnel all that stuff inside of our stack, so the developer API is exactly the same, but our stack, the architecture, stays largely the same, I think that's really cool. Since we've used WCF, I figured I'd show you this because it's not necessarily intuitively obvious when you look at it. So that's kind of cool. But then the question becomes, where in the heck is this web operation context thing coming from? So if we look at the operation context .current, we'll see that there is an extension property in the operation context.current. And again, if you've used WCF before, this will be a little bit of a review for you. But if you drill into this a little bit, you'll see that its count is 0. So there are no extensions in operation context.current. Remember I said web operation context.current was a cousin of operation context? And I want to show you how that works. So if I go to web operation context, look at what I've got access to. Incoming request, outgoing response. Fantastic. Let's drill into the incoming request a little bit and look at the headers. Oh yeah, there's all of our stuff, right? What's our content length? What's the method that we've used? What's the URI template match? It's all there. It's all baked in. Now, where did this thing come from? Well, let me make sure I got my spelling right. If we take another look at the extensions, we'll see there's now one there. So the web operation context, when you call the current method, it will go out and add an extension to the operation context.current. Right? So it's not there. There are no more objects on the heap when this is running until you do it on demand. And then we add it there. So this is all just a shortcut for us to find that stuff that's in the message properties and make it more visible to the developer. That's what we're doing. So we're flexing these 3.0 extensibility points to make this more visible. My girlfriend got me this shirt, and I feel like it's too short, so if I raise my arms in the air and my belly hangs out, I'm sorry. Yeah. Yeah. So that's the stack, right? So that's the core part of how this is working. Now, I want to switch it up a bit to say, all right, I've seen how to do the get. What happens when I use something like a post? So I'm going to change this to web invoke, and I'm going to set the method to, how about post? All right. Actually, before I do that, I'm sorry, guys. Now we're cooking. Let's see what this looks like on the wire, for starters. All right, so I'm going to start this up just like it was. And here's our model there. Get rid of the breakpoint. So now we're cooking with gas. So I'm going to open up Fiddler, which is a really cool tool. I'm sure you guys have all seen it. And I'm going to, instead of using localhost, I'm going to switch over to something that's hosted on the web, in IIS rather. All right. Now we're cooking. And I've got to change this from localhost to Justin SM-mini-me. Let's name my laptop. So if I go to Fiddler, notice what the raw message looks like. So this is just the raw HTTP traffic. There are no surprises here. All right? Now let's say we change this from being, a get to
an invoke, and dealing with a post. I'm going to go back to Fiddler and use my request builder, and I'm going to drag this request on, and I'm going to change this to a post. And there's one other thing I got to do, and that is copy my content type header. Paste that. Go back to this and copy this. So with the post, I want to send an entity body in. All right. Now I'm going to execute it. Make sure I got the name right. Yes. There we go. So let me zoom in here and show you what I did. So all I had to do was change the URI because I don't have a URI template there. I removed the URI template, so I used the method name. I set the content type to be XML, and I specify an entity body. And what I get back is the string reversed again. Very straightforward. All I did was change the contract, and now my service is behaving very differently. Make sense? I see some befuddled faces. I'm not sure if I went through that too quick or too slow. All right, so I'll keep moving along. So really the question, and the thing that I glossed over really quickly was, okay, so we had this service that was using the auto host, Justin. We had this little auto host service that was running on localhost 6000. Cool. Now then you showed me something that was hosted in IIS. How the heck did that work? How did you take this thing that was running in the auto host and how did you shove it into IIS? Because that's literally what I did. So I created a website just like you would do in Visual Studio, right? Just created a website using IIS as the host. Now, I right-clicked on that project and I said, I want to add a new item. And I'm going to add a WCF service, right? I went ahead and did that. But I also added a reference to the assembly that's using my auto host. So instead of creating a new service in the web project, all I'm going to do is just add a reference and point to the one I've already built. What's so cool here is the real work of my service is being done in this little auto host, lightweight kind of a project. And then I can just port it really quickly into running in an actual web server. So it's that easy transition into actually deploying this thing that I think is so darn cool. But that's not all. I feel like I'm in a sort of TV sales kind of position. If we look at the web config in the website, how much service model code is there? There's none, actually. It was a trick question. So when I deployed this thing, I use 0 config. Right? I use 0 config. How am I doing that? I go to the service SVC file, right? Go to the SVC file and scroll over here to the right, and that's where the magic happens. Oh. So I set the factory equal to system.servicemodel.activation.web-service-host-factory. What that will do for me is create a service host with all the binding stuff there, with all the behaviors there, and it will try to load my service that's defined just to the right of it. So if I define my service in this test host, right, then I can simply add an SVC file to a web project, and then just change my SVC file, and I'm going. So that's one approach. That's the sort of easy, no config, no extra code kind of approach. And that's all I did here. Pretty cool. Yes, question?
So if you wanted to set things like message size or anything, can you still do that? With the service model?
So if you, that brings me to my next point. Very good question. So the question is, what if I need more control? That's the thrust, right? What if I need more control over this? So there's another way, there's another approach that you could take that's got more flexibility to it.
So I'm going to show you how to write this stuff imperatively, and then we'll show you how to set it in config. Okay? So the idea here is if I don't really want that sort of no config approach, I want more control, more flexibility, then you've got a couple of options. One, you can do it all imperatively, or you could do it in config. I'm going to show you the imperative approach first. So if we use the imperative approach and we use the core building blocks that are in 3.0, we can new up a service host. Right? Service host was there in the .NET Framework 3.0. We can just new up a service host. Now we need to add an endpoint to that service host, and we're going to use the web HTTP binding to do that. That binding ensures we've got the right message being sent, the right message version being sent, and the right serialization infrastructure in place. That's part of the equation there. After we've got the endpoint, then we need to add the web HTTP behavior to the endpoint. So this is the behavior that sets up the dispatching stack, among other things. That's one of the things it does. So it talks to the service model to say, all right, we need to dispatch messages differently. We need to use a URI. And that's one of the jobs of that web HTTP behavior. And then we just open the service host. That's one approach. It's not hard by any stretch, just a few lines of code. But we thought, wouldn't it be even easier, wouldn't it be cool if we could even remove some of those steps in an imperative model? So we created a service host derived type. So it's got the same lineage as service host. And you just new up a service host, and you can pass in the type that you want to host and the address, and then you just open it. And it takes care of creating the endpoints for you and the behaviors and all that other stuff. It just works. Really cool. So this is another approach. If you don't want the imperative-driven approach and you want to do config, that happens to be what we do out of the box. So our default behavior here, if we say add new item, and I'm just going to go ahead and create this thing. Our default approach is to create the endpoints for you in config. So when you add a new service to a web project, you're adding config data into your config file so you can change it to be whatever you want. You can set all the quotas, you can turn on streaming, you can go hog wild with whatever you want to do. Right? And also I showed you kind of very quickly that we've got the ability to change config using this really cool tool that's easy to use, actually. So if I just right-click the config file and say Edit WCF Configuration, Shazam, it's all there. Oh, that's so much easier than twiddling around with XML files. Like, people that do this inside of Microsoft, like, all day, or use WCF all day, like, we use this tool because it's just too hard to parse manually. So I encourage you to check that out. The idea is we want to give you choice, and we want to make it easy for you as well. That's the concept. Okay. Back to slides. Any other questions before I transition back to slides? Yes? Multiple contracts with the same method. Multiple contracts for the same method. Are you talking about this thing, operation contract do work? This. Multiple contracts pointing to this method.
I think he's asking if you have web invoke and web get at the same time.
No, you can't. So it's a web invoke or a web get. It's a view it or do it. And that follows what the trajectory of your method implementation will look like. So you're going to have one method implementation that has no side effects if it's a get. If it's a invoke, you're going to have an implementation that creates side effects. So allowing that sort of coupling doesn't map well to the intention of web get and web invoke. Make sense? Okay. Back to slides. JSON. We all know what JSON is. I thought I'd throw this slide in here just because. But I won't go over JSON. If you got questions about what it is and what it means and why it's important, come see me afterwards. But we added some JSON-centric types in WCF to make it easier to work with JSON. We added serialization support that if Eugene is still here, he was the PM that ran that. Right? So there's a really cool JSON serialization stack that largely uses 3.0 serialization extensibility points, right, to work. And the key type in this stack, this JSON serialization stack, is the data contract JSON serializer, and it's meant to bridge objects to a JSON encoded message. Really, really cool. And we've also got some lower level types that are XML dictionary reader and writer derived types that you don't create automatically. You've got to go through a factory that's the JSON reader writer factory. So that's all goodness. The idea is I can take a class like some class that's annotated with the data contract attributes and the data member attributes. I can pass it through this serializer, and I get JSON out the back, which is really cool. There's a lot more capability there that we can go into, but that's the concept. We want to take our WCF core and say now we're going to spit out JSON as opposed to XML. Use the same general approach, but the implementation of this serializer is obviously vastly different because the constructs inside of JSON are it's a different grammar than XML. Just plainly different. Order matters, for example, by default. So there's a lot of those little interesting points there. So how do we use that interesting serialization infrastructure in our WCF endpoint? So there's a couple of approaches you could take. You could say, I am going to use JSON on its own. So I think JSON in and of itself is really, really cool, and I want to do sort of high-resty kind of APIs with this infrastructure. So that's really cool. You can set the request format and the response format in your web-get and web-invoke attributes, and you're basically going to say, do I want XML or do I want JSON? Right, so that's one approach. There are other sort of lower level approaches if you want to take those that have to do with the channel model and whatever, but I'm going to stick with sort of the normal mainstream kind of a path. And then when you're done with that, you need to make sure that you add that same behavior, the web HTTP behavior, to the endpoint. And then you get all goodness. You get the RESTful sort of web-centric approach with spitting back JSON messages on that endpoint. Now we also have the option to integrate with ASP.NET AJAX. ASP.NET AJAX. So instead of adding the web HTTP behavior to an endpoint, if you want to integrate with ASP.NET AJAX, you're basically saying, I want stuff like a JSON proxy, a JavaScript proxy, so that when I'm using Visual Studio and I'm setting, I'm calling back to that service, I just want it to work. I want to have IntelliSense, and I don't want to have to go through XML HTTP request unless I absolutely have to. Right? So we create a JavaScript proxy for you, and to turn that on, you need to use the web script enabling behavior, which is an interesting name. Right? So you turn on this web script enabling behavior, you add that to the endpoint, and you get this JavaScript proxy. We also add other constraints to the contract, and those being like you can't do puts or deletes. And the reason is the AJAX stacks that are in use today tunnel puts and deletes really over posts. So we enforce those other sort of rules in the endpoint. Now, if you don't want to add that behavior to the endpoint, if you say that's too much work, I don't want to do it. If I do that, everything's going to fall apart. I don't want to do it. So you can use some other drive types, the web service host factory, namely, and I'll show you that in a minute. So we have full support for this in the client stack. What I mean is we'll create the JavaScript proxy for you. So if you're using ASP.NET AJAX, you get the ability to call into any kind of WCF JSON service by default. Gives you IntelliSense, and we also give you the option to work without config, just like I showed you in the previous example. And this also works in ASP.NET Medium Trust, which is all goodness as well. So let's see it in action. No freeze this time. That's fantastic. All right. So the first thing I'm going to show you is the basics of working with the serializer. Right, so I go into JSON serialization basics, that method, and I'm going to new up a data contract JSON serializer. And I'm just going to use that type that I defined earlier. I new this up, I'm going to new up a stream, and then I'm going to write an object to that stream. Wahoo. That's all there is to it. So now when I read that stream, I've got back JSON. That's all there is to it. Right? And if I want to deserialize out of that stream, so let's say I've got JSON, I've just received it off the wire, I've received it from somewhere, and I'm doing this the hard way just by using the serializer natively, then all you got to do is call read object. Right? And you get back, and you've got to do some type inference there to figure out what it actually is. And then you can, of course, extract the values. It's non-trivial. There's one other point I should make about this. It's if you were the reckoning sort of person, how long do you reckon it would take to get all this stuff in the stack? The HTTP support, the new serialization support, the Visual Studio integration, and all the other stuff that we did that's not related to the web, like new standard support. We did this in a very short runway, right? So Orcus, the 3.5 bits were officially released beginning of this year, late last year, right? So we're not talking about a 5-year window. We're talking about year-ish plus a little bit of extra fudge time in there, window. Pretty cool, right? So we've got new serialization support. Let me show you some of the basics for hosting this thing. So if I go down here to my class and I say, you know what, I'm going to host this service, and my contract has web response format set to webMessageFormat.json. Then I can use the web service host to work with that type, and then open the service host, and now I'm listening. Really easy. So my contract has web message format set to JSON, and I just use the web service host, and all is right with the world. I've got the right behavior, I've got the right endpoint. Now, what if I take that a step further, and I say now, instead of using that response format and the web service host, I want to add the web script enabling behavior using that same service contract that we just saw. Now I'm going to throw. And I throw because endpoints using the URI template cannot be used with the web script enabling behavior. So if you make the mistake of using URI templates with the enable web script behavior, then we throw an error that gives you some idea of what the problem is. The reason we can't do this, the reason we can't use URI templates in this behavior that's intended for ASP.NET AJAX integration is there is no analogous JavaScript client for URI templates. Right? So it just doesn't map well into that world. So rather than allow the possibility of an error, we erred on the side of being conservative and said we're not going to allow it. So if you add the web script enabling behavior to an endpoint and your contract uses URI template, we throw an error. And we throw an error before the thing starts. Yes?
When you have to specify your data contract there during the set JSON format, why don't you just interpret the header coming in from the client and return JSON automatically if that's what you're asking?
So the question is, why don't we do content negotiation out of the box for JSON? And so in the fullness of time, those sort of more restful kind of views of you do content negotiation and how you would map exceptions to response codes is something that we're looking at. Right? So this is a first step, given the short runway that we had. We wanted to get this support into the stack. And that's a very good question. It's a common question. And in the fullness of time, as a team, it's something that we're looking at. Okay. All right. So we've seen a little bit about the web message format and the enable web script behavior demo. I want to show you one more bit here about JSON. And so let's say I go back to my IIS hosted project. I go back to my IIS hosted project. How do I do this? How do I host this JSON service without the need for config. That's all I got to do. So I changed the factory to the web script service host factory. And now, since I'm adding a reference to that type that's auto-hosted, I'm saying, all right, I want to take that service and expose it as JSON. ASP.NET AJAX-centric JSON. That's all there is to it. So you're deferring, by using that little auto-host project that seems so trivial, you're giving yourself a lot of flexibility later, which I think is pretty darn cool. All right. Now, after you've got that in your page, I'm starting to run out of time, so I'm just going to kind of zip through the rest of this bit here. After you've got that in your page, we integrate with the script manager, the ASP.NET AJAX script manager. So you can add a script manager and then point to that service, and we'll automatically generate the proxy for you. So you can then go into your JavaScript code and say, I want to new up a proxy, and then I'm going to just call a method on it. That's so much easier than working with XML HTTP request, I think. Right? So it's all done for you out of the box if you turn on this enable web script behavior. Okay. So the one other topic that I wanted to cover today had to do with syndication. Has anybody tried to build a syndication by hand in here? A couple? All right. Has anybody worked with syndications before? You guys are either asleep or you just don't do syndications. The idea with a syndication is it's a way to represent a set of data. And there's two formats that are out in the world today. There's RSS and Atom. There will certainly be more in the future. Who knows? But we in the .NET Framework and WCF decided to implement a first-class sort of implementation of syndications. So we want to make it easy to serve and consume syndications, either with or without WCF. And there's a couple of types that are really important. There's the syndication feed and the syndication item. Really straightforward. And the idea is we want to make it easy to create or consume syndicated content. So you're not having to parse XML. That's the idea. And if we look at some code that I've already written here for syndication, we'll see some of the features that are just in the stack. All the code I'm about to show you is available on the web. It's in a sample called Picture Services. And if I zoom into the address here, it's samples.netfx3.com/picture services. So all the stuff I'm going to show you, you can go out and get on the web today. So the idea here, if I open up the project, is that we use that simple auto host that we've got. We have a simple contract, and we're going to do a few things with this contract. One, we want to make it easy to return a feed, excuse me. So we've got a method here called getPicturesAsAtom. This whole sample is about serving pictures. It's about serving syndicated pictures, kind of like Flickr does. Okay, so this is just from your desktop. So getPicturesAsAtom. It's going to return something that's of type Atom10 feed formatter. So this is a formatter that will spit back an Atom feed, something that's Atom10 compliant. There's a cousin to it called the RSS20 feed formatter, right? And it's really pretty straightforward to use. So if we go to getPicturesAsAtom, we basically new up a syndication feed, and we've got some properties that we've got to set on the syndication feed, like what's the title of the feed, what's an ID of the feed, all that kind of stuff is settable in the syndication feed type. And then we've got to set the items of the feed. The items are all the things that are in the feed, all the entities that are in the feed. Okay? And we just go grab an IEnumerable, and we set that items to our IEnumerable. Pretty straightforward. That's our syndication. Now, how much code in here is really specific to RSS or Atom? Well, it's not really till the very bottom here when we call getAtom10 formatter. So feed has a couple of interesting methods on it related to formats. There's getAtom10 formatter and getRSS2 formatter. One will return to you an Atom formatter, the other one will return to you an RSS formatter, which means I can take URI segments at runtime and map them to RSS and Atom, which is kind of cool. All right, and I'm kind of rushing through this just because of the time constraint. But if I run this really quickly, notice we've got an HTML page coming back as well. So this is being served using WCF. And our return type is just a stream. So we don't have to serve back just RSS or Atom or XML or JSON. We can serve back anything we want. And in this case, we're just snewing up some HTML and spitting it back. I'm in no way, shape, or form asserting that WCF is a replacement for ASP.NET. This is just kind of stupid pet tricks with WCF. Okay? So then I can click on this pictures link, and we get back pictures that are coming from actually Windows Desktop Search. So the implementation of where I'm getting these pictures is Windows Desktop Search. This is me in India, and some other interesting photos here. Like, I'm from rural Georgia, and these are a couple of my childhood friends, Mike and Wes. That's me in camouflage. There's no laughter. This was intended to be funny. Anyway, so I think you get the idea there. Now, with the stuff that we're doing in the services world, there's some other really interesting stuff you can do here. And this is a teaser for a talk that I'm giving tomorrow. So I've got another project here that's using that core or that base for this picture services sample. And I'm going to go out to a different website. Take a look at what that website is. That looks like a publicly visible website. But there's this horrific sort of dotted segment there called BizTalk. Connect.biztalk.net/services/justinjsmith/feed. I'm using that same core to connect up to services in the cloud. And basically what I'm saying is I've got an endpoint that's on my machine that is behind a firewall, but I want to serve up in a RESTful way that service out to the big bad world. The services that we've got running out in the cloud in BizTalk services are saying, if you make a get or a put or a post or a delete on that public endpoint, we're going to secure it to make sure that only those that you deem necessary have access to it, but then we'll route it back to your service that's behind a firewall. Kind of cool. And that's what we're seeing here in this sample. And that's what I'm going to be talking about tomorrow, bright and early at 8:30 in the morning, is how this works, how those services work. We think this is huge. This model of pushing this kind of functionality, core functionality, out into the internet. Okay, so with that, I'm going to stop. And we've still got a few seconds or minutes, rather, for questions. So if you guys have any questions or comments, you can give them to me now. I'll also be up here at the podium a bit later. And last but not least, I have to say this. It's your potential and our passion. So guys, thank you very much for your time. I'll take some questions.